Hi, seventh graders. Hopefully you had a nice weekend and a couple extra days to either get caught up on your homework and all of your classes, or maybe you are already caught up. Um, I truly, truly miss seeing you all, and I hope that you're all doing well. Um, hey, we're in May already, and we only have, what, 4 weeks left, and then it's summer and we get a break, and hopefully we're back to school in the fall. Fingers crossed. I don't know about you guys, but I really miss being at school. So today we are going to start talking about scatter plots. We are going to do this over 2 days. So you'll have a short video today with a quick assignment to do and then a short video tomorrow on scatter plots also. So what we're going to look at today is really just what is a scatter plot. When you are looking at this, a scatter plot is really a graph that shows a relationship between two sets of data. Let me make this a little smaller. Shows relationships between two sets of data. Okay, so really you're just comparing what's happening with two different sets of data. And in this case, we have two different ones to look at. The first scatter plot, you can see that a scatter plot is just scattered dots on a graph. Typically, when we see a graph, we connect the dots, but not in this case. So we are looking at this first one is television size and price. And based on this scatter plot, I could ask some questions like, what can you tell me about the size of a TV and the price of it? And I would typically say that as the size gets larger or as the size increases, the price also increases. Now we can see that here is a TV that is about 65 inches and it costs $2,500. So it's a little bit cheaper than maybe the 58-inch TV, but maybe it was on sale. The second graph here shows people's age versus the number of pets they've owned. Now you can see that these dots don't go in a line at all like the first graph. They're kind of scattered all over because there's really no relationship between your age and how many pets you've owned. You can be 70 years old and have only had one pet, or you could be 30 and never had a pet. Or 40 and have had 6 pets, or maybe you're 10 and you've had 20 pets. I don't know. So there's really no relationship between that. Okay. The other thing that we're going to talk about is something that's called the line of best fit. Okay. So the line of best fit is the line that comes closest to all of the points on the scatter plot. So these two scatter plots do not have labels necessarily on what they're about, but I can take a line and we're not going to connect the dots. We're just going to draw a line that kind of shows the direction in which the data is moving. So this first line, you can see that as this number on the bottom is increasing, this number on the side is decreasing. So that data is going in that downward motion. Okay, on the second one, if I drew a line of best fit, okay, the line of best fit has to have about the same number of dots on each side of it. We can see that that data is going up. As one number increases, so does the other. Okay, now as we work on scatter plots, we can draw scatter plots and then we can use the scatter plot to make some predictions and answer some questions. So I'm going to draw this scatter plot. For this scatter plot, we're going to put, well, let's see, let me change my color here a little bit. We're going to put height on the bottom and weight over here on the side. Okay, and then we're going to add some labels to this. So height, let's put 0 right here at the corner. Let's go 68, 69, 70, 71, 72, 73, and 74. And then up this side, let's say we've got a weight of 160. See if we can get the next one in here. 170, 180, 190, and 200. Okay, let me scoot this around just a little bit. There we go. Okay, and then we just plot all the dots. Okay, and really don't make this difficult. We're just plotting the points. So a height of 71 is 170 pounds. We put a dot there. 68 is 160. 70 is 175, so about right there. 73 is 180. And 74 is 190. Okay, now we can draw a line of best fit. The line of best fit would look about something like that. Okay, and if I had to describe this data, I might say that as a basketball player's height increases, so does their weight. Which to me makes sense, that if a basketball player is taller, most likely they weigh more. But we can see right in the middle here that we have somebody that is 71 inches tall that weighs less than somebody that is 70 inches tall. And that can be true too. Like maybe somebody's just really tall and scrawny, okay? And then we have somebody else who is like buff, and so they're gonna weigh a little more. Okay, we can also make predictions and answer some other questions. So letter A, if a basketball player is 72 inches tall, how much would you expect them to weigh? So if I look at 72 inches tall and I follow this graph up, it kind of lands right on the line here. So I would say that I would expect them to weigh about 180 pounds. Now that's not exact. Maybe they weigh 185 pounds. We're not sure, but it's going to be about that much. The second question, if a basketball player weighs 165 pounds, how tall would you expect that player to be? So instead, I'm going to go over to the weight side, and 165 would be about right in here at 165. And I follow that over to the graph, and we want to know about how tall would you expect them to be. I follow it down to the height, and I would say that that person is about 69 inches tall. Okay, so your homework today is going to be to look at a few scatter plots and make some predictions and answer some questions about those scatter plots. And then you are done for the day. I do want you to get a score of at least 8 on the quiz. So if you don't get 8 out of 10, I want you to try it again. They are all multiple choice questions, so it shouldn't be too extremely hard. Thanks, guys. Have a great day. See you tomorrow.